The name of the chapter is Electric Field. Some people joined late, so I'm quickly recapping. The name of the chapter is Electric Field. Electric Field is a title which is in A2. It was in AS. A part of this chapter is now coming from AS because they shifted the AS version of this chapter into A2. The first part of this chapter covering AS version we have started. The first concept to be discussed is electric field. Electric field is a region in a space around a static charge in which a test charge experiences a force of attraction or repulsion. This is basically a concept of electric field. Electric field means a field around a static charge. When a charge particle is not moving, it produces an electric field. Now, everyone has to copy down the definition. Electric field is a force field. Electric field is a force field. Now, how this field is created? You take a positive charge, a test charge. You take a test charge, you put it at a place around the test charge. You will see a field. That field is called electric field. What is the test charge? Let us define once. Physics says, our course says that test charge is a small positive charge that feels the force of the electric field without distorting it. I mean, it's like a receiver, like mobile phone. Your mobile phone is a test material. Why? It doesn't disturb the Wi-Fi field, but it receives the signal. This is called a test charge. So this will be our second concept for today. That look, any charge like electron, proton, a positive ion, negative ion can be a test charge provided it does not disturb the field, it just experiences a force. Like here, small q is a test charge. This is our second concept for today, so I have to copy this. If you people have any query, you people can ask over the mic, is always welcome. And normally, when you draw such diagrams, technical neatness is needed. I mean, it should be neat in terms of physics. A test charge is defined as a small positive charge that feels the force of the electric field. You have to copy this. This will be the second concept. Let me know if you people have copied it. Good. Now, this is our second concept. Now, what are the example? The best example of an electric field is an atom in which electrons are orbiting the nucleus. One of the best example of an electric field, look at this. This is an electric field. Why? Because the nucleus has a positive charge and the electrons are orbiting around the nucleus. Why electrons are orbiting the nucleus? Because electrons are being attracted by the positive nucleus. Now we put our third concept. This is something we had discussed before also, and it will come at least once more. Field lines. Acha, field lines were in our course also in our O level, and we used to have this idea that electric field, magnetic field, they are drawn by imaginary lines. Look at this field lines. These are the imaginary lines. When you draw these lines, you want to show the field. Actually, electric field is invisible. So we draw lines of forces. Look at this. These are called field lines. We call them flux also. And the unit is Weber. Why we draw these lines? We draw these lines because the field itself is not visible. So now you have to copy, sorry, you have to give the heading field lines or flux. Now let's move forward, putting the concept. Look, flux or lines of forces, they are imagination. Actually, the lines are there, but we you can say that lines are our imagination because we want to show the field. The field itself is not visible, so we draw imaginary lines which can show the field, the presence of the field. Now look, the central charge is positive. The central charge is positive, and you can see that the lines are directed away. Now this was a convention. This was a convention in our O level. That how we show these lines. We show these lines by by using the idea of straight lines pointing away. Direction is very important. Positive lines will be pointing away, negative lines will be pointing towards. I repeat, positive pointing away, negative pointing towards. Now you have to copy this. Hmm. The central charge is positive. The lines are pointing away. This is a convention. Remember that flux is an imagination and flux has a unit Weber. Flux has a unit Weber. Hmm. Now let's move to our next concept. This is a radial magnetic field. This is a radial magnetic field. The radial means it is towards the radii line. Now look at carefully the negative sign. Now what was the convention? Positive, the lines will be pointing outward. Negative, the lines will be pointing towards. You have to copy this. Let me know once you people have copied it. This diagram should be drawn neatly. It should be symmetrical diagram. Make a good neat diagram. Copy this and update once you have copied it. Now, the field lines, which are imaginary lines, actually they are based upon the idea that these lines are always pointing towards they are always pointing away from the positive and always pointing towards the negative. Now, these are called field lines. They never cut each other. These lines should never cut each other and they should follow a symmetry. Now, I put my next title of this chapter. This will be the second title, maybe the third, I think so. Electric field strength. The symbol is capital E. What is the concept of field strength? What is the concept of field strength? Field strength is basically a concept that, like you say, mobile signal strength, Wi-Fi signal strength. signal strength is basically the Signal strength is basically the concentration of the signal. So if Wi-Fi signals are weak, you cannot get more data. Similarly, gravitation field had a strength. Electric field also have a strength. Why I am mentioning gravitational field every time? Actually, this chapter will make a club with gravitation, and you will see many questions where examiner is talking about electric field and gravitational field together. It is like a merge concept, and in A2 this is common that they make clubs in chapter, like circular motion and gravitation is a club. Electric field strength means the power of the electric field, how much field is strong. Let us put the definition. It's an important definition which comes: force per unit positive charge, and it's a vector quantity. So it's a vector quantity. Now you have to copy this. It is a vector quantity. Remember the definition now. It's a very similar definition as gravitational field strength. Now, this is a stationary charge, capital Q. This is the stationary charge who is producing the field. I mean, this is the source of the field. This is the source of the field. Now, look at in the line of the charge, I have put a small test charge Q. The repulsion, positive repulsion is working, and I'm getting a force on the small q. Look at the formula. E is equal to F upon Q. Electric field strength is the force per unit charge. You have to copy this. Now look at this. Now this time I have selected a negative charge which is in the center, and a force is now towards the charge. Formula will not change. Formula will not change because the formula actually shows the magnitude. But now the arrow of the force is opposite. This time it's a force of attraction. Remember, capital Q. Capital Q is the source. The red arrows are showing a radial electric field. Now you have to copy this also. Now, our next concept for today, the unit of, because it's force upon charge, because it is force upon charge, so unit of E is Newton per coulomb. Force upon charge, so it's Newton per coulomb. This formula is valid for point charges. Point charges are those which have a charge on the center, like point mass. So this formula is valid only for point charges. All the charges are not point charges. The same thing, that the charge should be at the center. So the formula says, now we say that the unit is Newton per coulomb. Why Newton per coulomb? Because it is force upon charge. It is force upon charge. Now you have to copy this. Now, let us make a sign convention. What is sign convention means? Sign convention means how you decide plus minus. So the small q, what is small q? Small q is the test charge. Like your mobile phone is a small q. It is a receiver. And the mobile phone is, just for understanding, not exactly a charge particle, but try to just like make a understanding. So the router, the Wi-Fi router in your home is the source, capital Q. If capital Q, if capital Q is plus, if capital Q is plus, E is plus. If capital Q is negative, E is also negative. If capital Q is negative, E is negative. So now you people have to copy this sign convention. Now give the heading electric field between two parallel charged plates. The heading is here. We won't start it today. We have done some work, and you people can just copy down the heading. As usual, a heading is there for the next class reference. Title is Electric Field Between Two Parallel Charge Plates. We have started a new chapter today. The chapter is Electric Field. It's a big chapter, heavyweight chapter, comes every year. A big question, challenging question. And this chapter is also related with gravitation. So now you people have to copy this. Once you people copy this heading, the class is over. You people can leave. The heading is electric field between two parallel charge plates. The topic is final for the sorry, the work is final for today, and we will be inshallah continuing this thing in our regular class tomorrow on campus.